We're looking over a prompt. According to a nationwide survey of randomly sampled 1,000 kids, 55 want to be a doctor. Find a 95% confidence interval to estimate the true proportion of nationwide kids who want to be a doctor. Let's break down the prompt. So right here I'm seeing a nationwide survey to randomly sampled 1,000 kids. So that's how many they talked to or how many they surveyed total. So then I know my N is 1,000. 55 want to be a doctor. So I'm not seeing any averages here or any means. I am seeing a success over a total. So 55 wanting to be a doctor. I care about who wants to be a doctor. I'm looking at a proportion or a fraction setup here of 55 over 1,000. That's how many want to be a doctor of how many they surveyed. Find a 95% confidence interval to estimate the true proportion of nationwide kids who want to be a doctor. So when we talk about a formal setup of a confidence interval, the first thing we want to talk about is what do we know about the confidence information? So what do we know about the population parameter? What are we trying to estimate? And what do we know for sure? We are estimating the true proportion of nationwide kids who want to be a doctor. What do we know for sure? We know for sure about the sample statistic. We know 55 over the 1,000 surveyed actually want to be a doctor. And if we change that to a decimal, we get 0.055. The next thing that we want to do is we want to know what are the assumptions and check to make sure that our data is good enough. So the first assumption we want to check is it random? So let's look through the prompt, and it says very specifically, randomly sampled. So here I'm going to put in quotations, randomly sampled. There is my proof. The next thing I want to check is independence. I want to make sure that one child isn't affecting the next one. I want to make sure that I didn't talk to too many kids that I could fear having some repeats in there. So the formal version of that is taking my total and saying less than 10% of the context. So let's go ahead and write that out. N is 1,000. So 1,000 is less than 10%, and my context is all kids nationwide. That really does make a difference, making sure we put all of them. And the last thing we need to do to verify that it's good enough data is we need to check to make sure that my shape is approximately normal. And to do that for a proportion, we're going to do our total times our p hat and our total times 1 minus p hat. We don't know about the population, so we have to use the statistics. This gives me 1,000 times 0.055, and this gives me 1,000 times 1 minus 0.055. Those numbers end up being 55 and 945. And the great thing is that both those numbers are bigger than 10, which is what we need it to be to verify it's normal. All right, next up on the requirements for our numbers is the name and number itself. So my name for this is going to be a one sample because I have one sample of kids. This is a proportion. Proportion interval. And my setup for the number is going to be p hat plus or minus my z-score times my entire standard deviation for our statistic. When I plug that in, I end up getting 0.055 plus minus my z star for 95% is 1.960. And we're going to be multiplying that by that big square root sign, 0.055, 1